Now we're going to talk about finding the x-intercepts and sketching the parabola. So let me say this, okay? When you sketch the parabola, all right, you definitely need to plot the vertex. If you plot the axis of symmetry, that's fine. If you don't plot it, that's also fine. If you do anything on my math lab, read carefully because sometimes they'll say just graph the parabola. Sometimes they'll say graph the parabola and the axis of symmetry. And you'll get it counted wrong even if you're doing it right if you've not completed the directions as they say. But we're going to be doing a worksheet instead for this point. But the other thing is you need plot 2 more points. All right. How do you plot 2 more points? Okay. You can plot the Y-intercept and the point across from it if the Y-intercept will fit on your paper. You could plot the X-intercepts, and that would be 2 more points in general. You can plot any random point, and I'll talk about that with you, and the point across from it. So we can use symmetry in order to get the point across from it, or you can use the A value to count out from the vertex and up or down. So if the parabola opens up, you'll count out and up. If the parabola opens down, you'll count out and down. Let's look at the x-intercepts because once we have all of our information, it makes it a little bit easier for us to figure out what's going on. All right, so I'm going to start here. The vertex here is -1, 5. And this parabola opens up. So -1, 5. And you'll notice that I only ever do the tick marks that I need. I don't tick mark everything because then you start taking up time that you may not actually need to take. Now on this one, I have a reasonable y-intercept. And the parabola opens up. So since the parabola opens up, I'm going to dot my axis of symmetry. Some of these stray dots are not me, it's the computer acting weird. So if I use the axis of symmetry, then I can get 0, 7 would be right here. Well, notice that is 1 unit to the right of the axis of symmetry. So let's go 1 unit to the left of the axis of symmetry and just go straight across, so that these 2 points are straight across from each other. Then you can actually sketch the parabola pretty quickly. Now I said I was going to look at the intercepts, x-intercepts. Sometimes I kind of go back and forth with this. Notice on this one, my parabola never touches or crosses the x-axis. So I can say on x-intercepts there are none. Now, I'm going to show you something, but I don't really want you to do this. I'd rather you use your visual interpretation and just say none and move on. But if I want the x-intercepts, technically what you do is plug in 0 for y and solve for x. So I would say 0 equals 2 times x plus 1 squared plus 5. I would subtract 5. And I would divide by 2. And then what I would do would be to take the square root of both sides. So plus or minus the square root of the left equals plus or minus the square root of the right. Guys, look right here. Whenever you take the square root of a negative, you know the answer is non-real. So non-real x values mean that you're going to get no x-intercepts. So instead of doing all the work and getting to the point you're like, oh, this is non-real, how about just look at the graph and say, hey, this thing does not cross the x-axis. All right, so on this next one, I can see already that my y-intercept is way too big to try to get into the graph. Let's go ahead and plot negative 4, 0 for my vertex, and this thing opens up. Okay. So negative 4, 0, if it opens up, then I basically have the whole graph in the second quadrant. So if the vertex is negative 4, 0, and it opens up from there, then this parabola is going to sit on the x-axis. Now, I want you to notice that the a value is 3. So if the a value is 3, that means count from the vertex out 1, up 3. If the a value is 1, you count out 1, up 1. If the a value is 7, you count out 1, up 7. If you do that, and again, the thing opens up, so I'm going to put my axis of symmetry upward. But if you count out 1 from the vertex and up 1, 2, 3, then you're right here. And then we know that points ought to be across from each other. So out 1, up 3 means you've got 1 right there as well. Now I can sketch my parabola. Now here is another one where I can already see that there's going to be a double root. So I'm going to say the x-intercept would be at x equals negative 4 is a double root. If your parabola sits on the x-axis or hangs from the x-axis, it's one repeated x value. So we could go through factoring. I just don't know if you'd want to, but remember, if you want to find the x-intercepts, you take the 3x squared plus 24x plus 48, and you make the y equal to 0. Well, guys, I see that 3 divides out of all of those, so I'm going to have x squared plus 8x plus 16 equals 0. Hey, I've completed this square before. I know that this is x plus 4 quantity squared, because x squared is first, x times 4 is 4x doubled is the 8x, and 4 squared is 16. So that tells me x equals negative 4 is a double root as well. So I can find it algebraically, but if I kind of start working my sketch, a lot of times I can figure out the x-intercepts visually, and then I don't have to do the algebra, okay? Now on this one, I've already talked about it. I actually kind of used 0.24, all right? I've also got the x-intercepts already, so really I used the vertex. I plotted it first or second, and the x-intercepts, and those made my 3 points. So that one I'm already done with. So at this point I've said enough, and instead of leaving it dotted, I'm now going to officially draw it in, and we've got that one. So on this one, let's see here. Oh, this one's not going to be a bad one. Now 0, negative 29 on my y-intercept, that's a little too low, so I'm not going to worry about that. Let me go ahead and plot the vertex at 3, 7. So at right 3, up 7, and then upside down. So right 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7. So there, it's not where I put it. And then the thing opens down, so my axis of symmetry is going to go down from there. Okay. Now on this one, I can't use the y-intercept, but the a value is easy. Since the a value is negative 4, that means from the vertex, count out 1 down, because it's negative 4. So let's see, if I count out 1 down 1, 2, 3, 4, that's here. And then if I say I know I've got to have 1 right across from it, it would be out 1 and down 4 on the right-hand side as well. Now, my graphs aren't great, but now I can tell I actually do have x-intercepts. I see that I've got 1 here and 1 here. Now, I can't tell from my graph where they are. I can tell it looks like, even though my graph's not perfect, it falls between positive 1 and positive 2, and then maybe again between positive 4 and positive 5, but I don't know exactly where. So let me go through finding the x-intercepts, but I do know that there are two x-intercepts. So on this one, I actually need to flow through the process. So remember, you set the equation equal to 0 instead of y. This is an equation where I can take square roots of both sides. I'm going to divide by the 4. So negative 7 divided by negative 4 is positive 7/4. Take the square root of the left and plus or minus the square root of the right. So that's the square root of 7 over the square root of 4. So that's going to be x equals 3 plus or minus the square root of 7 over 2. So I added the 3 and I simply took the square root of the 4. Guys, I notice that the square root of 7 cannot be broken down, so I'm actually done. But here's what I want to do. I'm going to get my calculator and I'm going to say, well, what is this? So I am going to say, let me punch in on my calculator the square root of 7, so you could do that with me, enter, divide by 2, enter, and I'm going to say 3 plus that answer. So to about 1 decimal place, I'm getting 4.3. And then if I say 3 minus that answer, I'm getting 1.7-ish. And I'm just rounding to 1 decimal place because you can't do much better than that anyway. But look, this is between 1 and 2. So that makes sense. I didn't know where it was, but I knew it was somewhere right in there. This is between 4 and 5. So between 4 and 5. So what I'm showing you is that the sketch told me that I did have x-intercepts to find. Now, these are the answers that I'm going to ask for. I did the decimals only to see if what I did with my algebra syncs to what I did with my graph. And I can see that it does. My intuition made sense. So I used the graph to kind of check my algebra work. Now on this one, I'm going to start with my vertex. So right 8 down 5 and it's right side up. Okay, so I'm going to say right 8 down 5. And notice I went ahead and decided I would draw in my axis of symmetry. Now, the parabola is 0.27. That's way too tall, so I'm not going to use that. All right, now your A value is 1/2. This is a time where the way you have to count out and up is a little different, and I don't want to explain it to you in the video because I'm afraid it will mess you up worse. So I do know that the parabola is right side up, and I know if I kept going, I don't know how wide it is, but clearly the parabola is going to cross the x-axis, okay? I don't know where it's going to cross the x-axis, so let me find the x-intercepts. The x-intercepts will help me get some more points that I can plot. So I know that I need to say 1/2 x squared minus 8x plus 27 equals 0. I never solve an equation with fractions, so I clear the fractions. That's going to give me x squared minus 16x plus 54 equals 0. Let's see here. My AC is 54. I'm trying to see if it'll factor. It's positive 54, but I need a negative. So I need two negative numbers that add up to negative 16. So I know I could do 1 and 54. That's clearly not it. 2 and 27. That's not it. 3 and 18. That's not it. 4 doesn't go into 54. 5 doesn't. 6 and 9. I don't think, because 7, 8 don't go in, and then 9 times 6. None of those are going to add up to 16. So what I'm thinking is that I've got messy x-intercepts. So I need to figure out, can I solve this guy a different way? Since it won't factor, the answer is yes, I can. Since the 16 is even, I am going to do complete the square, because when complete the square is fast, it's faster than quadratic formula. So I see an x, I see a minus sign. Half of 16 is 8. Squared is 64. Well, that's not where I wrote that. Negative 54 plus 64 is 10. So x minus 8, take the square root of that side, equals plus or minus the square root of 10. Take the square root of that side. So x equals 8 plus or minus the square root of 10. Guys, this is the answer that I want you to give me. But now let's figure out about where that falls on the x-axis. So if I simply plug in 8 plus the square root of 10, I think it's going to be 11 point something or other. Yeah, it's about 11.2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 11.2 is just somewhere in between them. So now I can get the right-hand side of my parabola, and I could technically do the same thing on the other. But I could also say 8 minus the square root of 10 on my calculator, and it gives me 4.8. So 1, 2, 3, 4. 4.8 again would be between 4 and 5. Notice I'm not like making much of an effort to make it look like 4.8 versus 4.1. I just kind of make them all look like they go right through the middle at 4.5 when I'm graphing. I don't try to be more accurate than that. So if it's 4 point anything, just make it cross between 4 and 5. Or if it's 12 point anything, just make sure it crosses between 12 and 13. Alrighty. So that time I figured out that there were x-intercepts, and I used the x-intercepts as my extra points. So now on this one, I have not, like I know the parabola opens down, but I have not found my 2 extra points. So let me erase this because I've not used enough information to figure out what this parabola looks like exactly. I just know it opens down. So let me get rid of the thing that I kind of just scooted in there real fast. Now again, I see that my A value is negative. Let me try to write with a pen instead of an eraser. If my A value is a fraction, it's really, really hard to use it to do my graphing. So I'm not going to use it. 0, negative 20 is too low. I don't have any other x-intercepts, okay? So I'm still down a point. I've got to find at least one more point on the graph. So guys, what I usually do is say, well, pick a point that's somewhere near the that's not where I meant to graph that. Somewhere near the vertex. Well, I would say since my vertex is at 10, how about I plug in, you know what I'm going to do? I could plug in 9, x equals 9. But I notice that I've got to take a fifth of my answer. So let me plug in 5 because I'm trying to think about what would work out nice and neat. So if I plug in x equals 5, then my y is going to be negative 1/5 times 5 minus 10 squared. And I'm hoping that will come out pretty all right. So negative 1/5. 5 minus 10 is negative 5. Squared is 25. A fifth of 25 means 25 divided by 5. That's 5, and it's negative. So I'm saying I've got this extra point at positive 5. There is nothing about what I just wrote that the computer put where I meant for it to. Positive 5 comma negative 5. Now that's not so outrageous that I can't plot it. So 1, 2, 3, 4, 5. 5 comma negative 5 is right here. Now, if I know that I'm going to go right across, then I could say, okay, if I measured about the same width on both sides, so 1, 2, 3, 4, 5, from the vertex out 5, down 5, now I've got enough information to plot a more decently shaped parabola. Don't worry if your parabola goes off the paper or off the screen a little bit. So those are all the different things that you can do. I hope that helps, and you let me know if you need help.